Now that we know the workspace and how to create curves, let's take a step further into creating surfaces and solids. Layer organization is essential in any project. To manage them, we use the Layers panel. In this panel, we can create a new one by clicking on this button, rename an existing layer by double-clicking on its name, or change its color. And through the icons, we can hide the elements of this layer or lock them. To move objects from one layer to another, we make a selection and right-click on the target layer and choose to move objects to this layer. Or we can open the quick access from the status bar, and with a selection made, we select another layer that has already been created. This quick access also tells us other things. For example, it tells us which layer the selected objects are in. If we have made a previous selection, or if we don't have any selection, it indicates the current layer. The current layer is identified with a tick, and it's the one where the geometry we create will be placed again. You can change it by double-clicking on another layer. I'm going to move all the curves to layer 1, which I will rename as curves, and you can choose whatever color you prefer. By default, objects are given the color of their layer, but this can be customized in the Properties panel. In Color, which is set by layer, select a color different from the layers, and it will be applied as a custom color. If we move on to the Modeling tab, the first one is Point Surfaces. This command creates surfaces from 3 or 4 points in space. It works as if we were creating a closed polyline that at the moment the command ends, with a right-click, or after the 4th and final point, it generates a face called a surface. By default, it projects onto the construction plane, creating a flat surface, and we can also activate its control points, which correspond to the vertices, and move them in space, so I can turn this flat surface into a 3-dimensional surface. To see it this way, we have the viewport in shaded mode. If we work in wireframe, what we'll see is this face represented with its wireframe structure. Next, the plane command creates rectangular surfaces. We have the option of corner to corner, or the option from 3 points. The dynamics with these is the same as what we've seen with the rectangles. We can select points in the viewport, or we can input them by entering coordinates. But since we already have the layout done, it will be easier to guide ourselves using reference points or curves. With the corner-to-corner plane, we also have the option to select vertical plane. And first we define an axis, and finally its height. Surfaces can also be transformed using the tools from the sidebar, such as moving, scaling, grouping, or splitting. For example, with the subdivide command. We can select the surface we've created, select the inner curve, and in this way have 2 distinct surfaces, allowing us to apply different thicknesses or materials. And with trimming, we can use outlines to remove parts of this surface. To show the tools for creating surfaces from curves, I'm going to display a layer where I've created some shapes to streamline the explanations. The following command generates planar surfaces using curves, as long as they are closed and coplanar contours. If they don't generate, check the object properties to ensure it's a closed curve. If it's not, make sure there are no open vertices, and that all the lines are joined using the join command. In case we've made any precision errors in the drawing and the surface doesn't generate, indicating that it might not be coplanar, we can activate the control points. We select all the vertices using Shift. And in the sidebar, we have a tool to align objects. First, I position myself in a front or right view. I select bottom alignment because I want to align them on the Z-axis. And we see that the points are now aligned. To place them, we can select the vertex as a reference. Surface from edges creates a surface using up to a maximum of 4 edges or open curves, without the need for them to be coplanar. We can even select edges or edges from other surfaces. Now, if I have, for example, 4 edges, but I don't want them to have continuity between these two, instead, I want to control the curvature. I can generate a network of curves that cross from one side to the other in one direction or in both. I'm copying this curve to give it a straight start. I'm going to isolate them to work better. A cross-section curve that passes through the midpoints of these two curves and connects tangentially with a straight line. To create a network of curves, it's necessary for all the curves to intersect with the curves in the other direction. For this reason, it's very important that if we create a profile using two curves, we join them into a single one. Now, with the surface from network command, we select the curves in an orderly manner, first in one direction and then in the other. And before finishing, it will show us the options for tolerance and also for continuity for each edge. Here we see that the maximum constraint is position. But what if instead of using curves, we used edges from other surfaces? For example, I delete this edge. I'll remove this one too, so it can be appreciated better. And now I'm regenerating the surface, choosing the edge of this existing surface. We see that for the edge referred to as A, which coincides with the surface, we have the option to maintain tangency with the surface or to match its curvature. And we see how it gets corrected. With patches, we generate surfaces that fit the edges of surfaces, curves, and selected points. And we don't have the restriction that they need to be coplanar. Before generating the surface, we have a series of options. We can do a preview, and we can also adjust the number of segments that define the surface. U corresponds to the direction of the x-axis and V along the y-axis. We can play with these values, understanding that the higher the value we use, it's as if we were dealing with a more malleable material and higher curvature. But we should try to stay at lower values as much as possible. These dividing lines that make up the surface are called isocurves, and you can control their visibility from the display panel by checking or unchecking their box. Alright, next we have the transition, which creates surfaces through several profile curves. Let's understand it better by seeing it. For example, I can select these ellipses one by one to define a planter. The order of selection is going to be important because the surface will follow this path. When we right-click, it shows this path in blue, and where it places the arrows indicates the starting and ending point of the surface. In other words, I would start from this line, it generates in this direction and ends at the same point. If we want to move it because it hasn't been generated correctly, we click on a point and we can move the cursor to change its location with another reference. And by clicking on the arrow, we can change the direction. We always need to make sure that things like this don't happen. Let's see what happens. We see that the surface isn't well structured. Instead, the isocurves are twisting. And this is something that can lead us to both geometry problems, and when it comes to applying materials, the textures are going to get distorted. Transitions can be used with any closed curve that we create. I'm going to create a bench using this profile. We can copy it and create variations of it. I create a symmetry using the reflect command. And we get, by making the transition, this type of tubular shapes. With the sweep tool, we create surfaces from two curves. The first one it asks us to select is the rail face curve, and the second is the profile curve. This is the one that will be extruded along the previous curve. As you can see, this process can also result in the isocurves not being the best they can be. To remedy this, I can rotate the profile aligned with the curve, now rotating it exactly 90 degrees. And this way, I ensure the perpendicularity between these two. Now if I generate it, we see that all these isocurves maintain a better alignment along the rail. To finish this section, the revolution tool creates surfaces by rotating a curve around an axis. Here I have drawn half of the profile of what would be a molar. So I can select the profile and revolve it around the axis I drew. We make a first click to set the start of the revolution, and a second to indicate the end. We can also input a specific angle, for example 180 degrees. We get half of a complete circumference. But if we want it to be 360 degrees, we can directly select a complete circle in the command options. And that's how we get a complete revolution. To create predefined solids, such as boxes, pyramids, or cylinders, we have predefined shapes with which we only have to follow the steps in the command bar. First, we usually define the contour dimensions, and finally indicate the height. When we have a closed object that encloses a volume, we call it a solid. This one in particular is made up of 4 surfaces, one for its body, another to cover the top face, and another for the surface on the bottom face. If we use the command explode, it separates the surfaces that make it up. And if we select it and join it again, we get a solid once more. In this square here, I'm going to make a sculpture so that when we look at the vegetation tools later, we can turn it into a topiary. For this small sculpture, I'm going to make 3 cylinders. To do this, from the top view, I mark an initial point. I input a radius value, like for example 0.05. And finally, the height. I'm going to repeat the command to generate a couple more cylinders of different heights, and I'll align the 2 at the back. The toroid, pipe, and sphere commands generate solids made up of a single surface that encloses a volume within itself. To generate a sphere, we indicate the center, which I'm going to align with the center of each of the cylinders. We input the value we want for its radius. I repeat for the rest of the cylinders and adjust their positions. With the tools we've seen, you can create whatever shape you prefer in this space. We can also create custom solids from curves and surfaces. With the curve extrusion tool, we can transform a curve into a solid by extruding it. For this wall, instead of cutting the surface, we can directly select its outline, right-click, and move the cursor to the side. We want to extrude it, and we can enter a specific value for its thickness. If in the options of this command we select solid, yes, we will get a solid as a result. On the other hand, if we select solid, no. It will only generate the extrusion of this curve. A flat curve is always extruded vertically towards the plane of the curve. If the curve is not flat, the direction of extrusion is the Z direction in the active construction plane in the view. Other options we have are to generate extrusions in both directions or modify the direction. To modify the direction, we always need a reference line. For example, if I have an open curve, I draw a line with a slope. And at the moment that I extrude this curve, I indicate this direction, taking a start point and an end point as a reference. And we see that now the direction is no longer the verticality of the z-axis, but rather follows the direction of this curve. This command works the same way, with the difference that the input to select is a surface instead of a curve. We can extrude the surfaces we have created so that they have a thickness. If we select to delete the original, when the new solid is generated, the original surface will also be removed to avoid having this duplicated face. I've given the outer part a thickness of 0.2, and for the inner surface, I'm first going to trim it to leave space for the water pond, and then I'll extrude it with a thickness of 0.3 and move it. To create this small elevation at the top, push or pull is a very useful tool for editing solids, adding or subtracting volume in specific areas. This tool automatically detects the faces of a solid and also the intersections with other curves. By clicking on a face or segment with the cursor, it allows us to move the face to create new extrusions or cuts, depending on the direction in which we move the cursor. With some faces in the command options, we see that the mode option appears that if we press, the M key allows us to choose between extrusion or extend. And with extend, it extends or shortens the face in this way. In the next section, we have tools to modify and optimize existing surfaces. Starting with surface offset, this allows us to create a copy of a surface or also a polysurface in such a way that all positions of the copied surface are at the same distance from the original surface. When we select the surface to offset, it shows us the direction of offset, which we can reverse, offset in both directions, and also decide whether we want to generate a solid or an independent surface. We enter a value for the distance, and with Enter or right-click, we finish to generate this new surface. Although it may seem like it, this surface is not a copy, because the curvature angle of the upper surface will be greater than that of the inner surface. With chamfer, we connect two surfaces with a straight bevel. When entering a distance, it asks us for two measurements. The first corresponds to the distance from the intersection of these two surfaces to the axis of the first selected surface. And the second is the distance from the intersection to the next one. For example, I set the first to a value of 0.5 and the second to a value of 1. I now select one surface and the other. And as you can see, this side here corresponds to a measurement of 1 meter and this other one to its half. I press Ctrl Z as a shortcut to undo, and now let's look at the fillet command. It is similar to the previous command, but in this case it generates a curve transition. We specify a radius and select two surfaces that share an edge or intersect. Before finishing, this options dialog appears that allows us to adjust the radius in a more visual way or choose the type of curvature. If we keep this on arc, we ensure that it maintains the radius we've specified along the curve, or when it's formable, we can edit the tangency with the adjacent surfaces. With this checkbox, we trim the excess part at the intersection. We can use these two commands to create joints or smooth corners. Next, we find the Rebuild Surfaces tool, which allows us to redefine the control points of a surface. If we rebuild a surface from corner to corner, we see a series of arrows drawn on the surface. The red arrow indicates the U direction, which therefore corresponds to this first value. In parentheses, it shows us the current points, which was a total of 2. One on this edge and another on the other edge. And next to this, we can enter a new value that we want, like for example 4. And the green arrows indicate the same in the other direction, which also started from 2. We can set a different value, but I'm going to leave it the same so we can see the difference. If we activate the control points again, we can see this modification. In this direction, we continue to have 2 axes of control points. In this one and in this edge. But in the direction of the x-axis, we've added 2 more points, giving us a total of 4. We can rebuild a surface to get a greater number of points, from which we can make an addition. If I now generate a shape by moving the 4 central vertices, we observe that in the first direction, the curvature is smooth. But in the other direction, we get straight segments between the vertices. This depends on the degree of curvature, so we also have the option to control the degree. A degree 1 corresponds to straight segments. A degree 2 results in a smoother transition, but it may have little flexibility. And with degree 3, we now have greater smoothness. With the following command, we create a symmetrical copy, so that the copied half is tangent to the original surface. The first step is to select an edge of the surface, and then we draw the axis in the viewer, from which we will create the symmetry, selecting a starting point and an ending point. The peculiarity of this command is that if the axis of symmetry we indicate is not in contact with the surface, it will extend both surfaces, the original and the copied one, as long as it maintains the tangency. If we don't want it to create this tangency or join the 2 copies, we simply use the reflect command in the sidebar. Alongside the surface editing tools, we also have this other group here, which groups options for solid editing. The first 2 are Move Edge and Move Face. With Move Face, we can shift a face, for example, if I want to extend this floor surface to cover this wall as well, without affecting the rest of the geometry. We select the face, the point from which we want to move it, and the final reference point, and that's how we would do it. Just as we have chamfer and fillet for surfaces, we have the equivalent for solid edges. With chamfer, we first indicate the chamfer distance, for example, 0.5. We select an edge of a solid, and it shows us that this bevel will be made with this value of 0.5. We right-click or press Enter, and these handles appear, which we can leave as they are and accept the command, or we can also modify them manually, and at the same time, it allows us to give a different value at the beginning and another value at the end. In this way, we will get asymmetrical results like this. Other options that this command offers us are to chain edges and select consecutive edges to apply the chamfer, or to directly select all the edges of the selected face. So I can select several faces at once and apply this smoothing to all the edges of the solid. With fillet, we have exactly the same options that we just saw, but with this one, we get a rounding on the edges with the radius that we specify. In both commands, we can also use them to edit. If I forgot to select any face or edge, I go back to select the fillet tool, choose the edit option in the command bar, then we select the solid and right-click, and we choose select edges to add more edges to the selection. Once selected, I preview and finish the command. And finally, in this group we have this command which automatically closes holes in solids with planar geometries. We select an open surface or polysurface, and it will close all the holes it finds as long as it can be covered with a flat surface. Alright, I'm going to hide all this additional geometry now, and let's get to know the Boolean operations that are used to combine geometries. I'm going to draw two flat surfaces with different shapes that overlap each other, and I'm going to make 3 copies. Remember that to copy from the gumball, you need to hold down the Alt key. The first 3 commands correspond to Boolean operations with flat surfaces. The first one we have is the union operation, which combines 2 surfaces resulting in a single one. With the difference operation, we subtract one surface from the other. The first surface we select is the one from which we are going to subtract the contour of the second. If I select the square first, I keep this part, and otherwise I get the part of the circle. And with intersection, we get the overlapping area between both surfaces. The other 3 Boolean operations apply to 3D geometry, joining, subtracting, or intersecting volumes. As we have seen now, for example, we can put it into practice by creating the walls of this water pond. I'm going to create 2 different solids. One with an extrusion from the outer curve and another extrusion with the inner line. Now I have 2 volumes. I'm going to move the inner volume a bit. And now I perform a Boolean difference operation to subtract one volume from the other. Reaching the end, the last group, they are tools that allow us to obtain curves from solids or surfaces. The project command moves a curve onto a target object. I'm going to generate a surface from an arc, and also a circle that I'll bring to the front, which will serve as a curve. The curves are projected vertically onto the active construction plane, so in this case, it's best for me to position myself in the front view. I select the curve or points that we want to project, and then select the target object, which will be the surface. We click again to finish the command. And this is how we get the same curve projected onto the object. The intersection command generates points or curves from the intersection between 2 objects. If I use this circle to generate a cylinder, I'm going to rotate it and cross it with the previous surface. If we select intersection and choose both surfaces, I finish the command, and now we can work with this curve obtained from the intersection of both surfaces. With the rest of the operations, we extract curves from surfaces or solids. For example, we have options to duplicate a selected edge. Duplicate the edge on a surface or duplicate the edge of a face if it's a solid. With this, we finish the breakdown of the tools in the Modeling tab. You can put into practice what we've seen in this tutorial to create the shapes you want in your workspace. I'm just going to finish extruding some curves to add thickness to some edges and review the project's layer organization.